I want to revisit a rate law equation that we actually discussed yesterday. So I'm going back to page 594 in Zumdahl, the 9th edition, in chapter 12 on kinetics. And so as we talked about yesterday, we're doing calculations for rate law. Rate law is how that you have a change in concentration for your reactants. And so when we look at a rate law, a lot of times they're going to give us this data here. You know that you're going to be using a rate law when you see the concentrations changing, and it tells you that they're in molarity here per this time for this initial rate. So this right here is kind of a dead giveaway that you're going to have to find a rate law. And so just lo and behold, that is the first question. Then we're going to calculate the value of K, which is your rate constant. And then we're going to add in these two things were done yesterday. But the last thing that we're going to do is actually calculate an initial rate if we have a certain molarity of the concentrations of the reactants that are given above. And so, like I did yesterday, I'm going to start off with giving you, this is the equation that is in the book. I went ahead and wrote this out just so that we could refer back and forth to that as we're looking at this together. Okay, so each of these is denoted by an actual experiment. And so I wrote those in so that we could actually draw to them really quickly. So for a rate law, this is a very standard form of the rate law. Rate is always going to be equal to your K value and then your concentrations of your reactants. And so when we calculate a rate law, we are trying to figure out what are the order of these reactants. What's this exponent X and what's this exponent Y? And so we're going to compare the concentrations of the experiments above to know what those values are for this rate law. So normally, like for finding X here, I'm going to use data from the top that is going to allow me to isolate X. And so for this particular one, I used experiment 1 and experiment 2. So I'm just going up here and I'm using the data that's written out here and I'm plugging it into this rate law here. So my experiment 1, my rate is what I'm writing here. K, and then this value here from the table is written there. Raise it to X. Concentration of OCl minus is written there. Raise that to Y. Okay, so I'm doing the exact same thing for experiment 2, plugging that in. So as was discussed in the last video, K is going to be the same on the numerator and the denominator, so this is canceling out. These two things raised to the same exponent are going to cancel out to be 1 as well. So that leaves this expression and this one for us to use to calculate. And so these two divided together gives me 2. These two divided gives me 2 raised to this X. So in using our math, we can figure out that X is equal to 1. So that means that this I minus is to the first order. So then we can actually go for this next couple of experiments to find Y. Now this one is a little bit different than what I've given you in the past, but I do want to talk about it, and it's good for discussion. So for this particular part, there is not a way for us to go through and have any of a repeated concentration for I minus like we did here so that we could actually cancel this out. We're not going to be able to cancel any out down here, but it works out. It's just using algebra. So I just picked experiment 2 and 3. I used the data table from the top up here again, and I plugged in values for experiment 2 and experiment 3 into that standard rate law. So through this process, K is the only thing that is going to cross out. But this is okay because don't we already know a value for X? We do. So we're going to go ahead and simplify. These two divided by one another is 4. These two, the value of 2 raised to the X. This is the value of 2 raised to the Y. All right, so we're going to plug in X. So that means that this is actually going to be 2. So I'm a big person about, like writing everything out so that we can see, we can verify what the calculations are going to be. So I've got 4 is equal to 2 raised to the 1, 2 raised to the Y. So this 2 here, I'm going to divide over to the other side to simplify. So that gives me 2 equal to 2y. I guess I could simplify that out. So 2 divided by 2 is, or 4 divided by 2 is 2. 2y. And so that's what allows me to know that my y is equal to 1. So what does this give me if I know x and I know y? That gives me my rate law, which was the question A. Rate law is going to be k times I minus raised to the 1, so that's why there's nothing there, OCL minus raised to the 1. So just sidebar question here, if you ever have a question that says what's your overall order for your reaction, well, this is first order, this one's first, so 1 plus 1 overall would be 2. All right, moving on. Part B, we did this one yesterday as well. Calculate the value of your rate constant. So when I look at the value of my rate constant, I can actually use any experiment that I want, 1 through 4, to plug data in and solve for K, because all of this is from the same reaction, so that means all of K is going to be the same. So in looking at this, what we're actually going to be able to do is just pick one of these reactions and plug everything into this rate law that we have now. So I always use experiment 1, like I was telling you yesterday or in the last video. I don't know why I always choose that one, I just do. So this is my rate law here, and we're using experiment 1 data. If you look back in your table, I'm just plugging everything in. This is the rate for experiment 1 equal to K, concentration of I minus, concentration of OCL minus. So in doing that, so in looking at this rate law, when I plug all of this information in, I am going to, just like I was telling you before, I like doing step-by-step work here, so that I have this rate is equal to K multiplied by these concentrations. So rate is equal to K, and then I took these two numbers here and multiplied them together to get 0.0216. Now, moles over liters multiplied by moles over liters gives me moles squared over liters squared. Now, in the last video, we talked about how to simplify these units, and so we can actually go back through and talk about how that we're doing each one of these things. And I mean, if you need extra help there, just message me, and I can show you how to algebraically go through and simplify that. All right, so if this was my initial part here, to where that I've got this is, I'm starting to simplify, combine like terms. Once I get here, now let's isolate and solve for K. So I'm going to take this and divide it over to the other side, and so that's what I did here. These two mark out. I'm going to divide this number by this number, and I get 3.66. And honestly, you can use 3.66 or you can round it up to 3.7. Either one, I think, according to AP rules of sig figs, would be fine. When we're looking at this, actually, I think it should be 3.7 because these have 2 sig figs in them. This one has 3 sig figs. So I think this should actually be 3.7 for my sig fig rules. All right, so now when we look at the rate constant, we can see that the K value is going to be 3.7, but now we have to take care of the units, okay? Remember how that you are, when we look at the last part of this, and so this is the newest piece of information from what we did yesterday, or in the last video. Now we want to calculate the initial rate of the experiment when you have a concentration or a known concentration for your reactants. And so in this particular question, both of them have the same molarity. It's not always, you know, they can have 2 different molarities. It's just whatever the molarities are for the things that are given, you're just going to plug those in. So if we know the rate law and we know my rate constant, all we have to do is plug and chug. We're going to use the rate law here, and we are going to plug the K value into the equation with the concentrations that are given. And I mean, so this is, you know, nothing here is hidden. We just calculated this. These here were given here. These could be 2 different numbers. Doesn't have to be the exact same. So we're calculating an initial rate if this concentration was given. So this was the rate law that I wrote from the initial concentration, or I'm sorry, from the initial calculations in part A. This was my value that I calculated in part B. This is the new information that was given, and so I'm taking all of that and I'm plugging it in. So this is just this with the data put in. K value, concentration, concentration. So here we plug everything in, but you also have to be very careful about your units. So if I'm looking at the way that the units are put together, liters over mole times second, concentration and molarity, concentration and molarity. So I wrote them out like this just so that you could get acquainted with how that I actually simplify. You've got liters here and liters here, so 1 and 1, those cancel out. Okay, so then you've got moles here and moles here from this molarity. Those cancel out. So that's why I've got them marked out. So now think about what you have left over. You have a mole in the numerator, you have a liter in the denominator, and then your second that's left over is terms of time. Well, rate is always going to be as a function of time. So in this particular question, it's seconds. So when we're looking at this, I'm just going to take the 3.7 times the 0.15 times 0.15. And so this tells me if I have these two initial concentrations for my reactants, this is the rate at which that reaction is going to proceed. Now, I've seen several questions before on AP exams to where that they make a big deal about not just the number value of your rate and your rate constant, but they just actually want to know if you can do the calculation like this. And so sometimes they'll just basically say, what are the units for your rate constant, or what is the unit for your overall rate? And so in that case, guys, go back and look over how to simplify these units. I mean, you guys, most of you are seniors, some of you are juniors, and so when you go through and you have simple questions like that that just asks about rate or rate constant and their units of those things, not necessarily the number, don't miss easy questions like this. If you have to go back and do 8th grade math and write these out just to simplify, to verify that you got them correct, do not be ashamed of that. Just write those out in the simplest form. Take your time. Look at them, because I have seen questions like that to where that they just say, what's your rate constant unit, or what is your rate unit? And so, be prepared for simple questions like that. If you have any questions about how to do number 33 from page 594, give me a shout, use my email, just whatever you need.